Hey everybody, I'm Andrew from Lampro Event Solutions. Welcome to our 5th online sound training session that'll be looking at crossovers, amplifiers and loudspeakers. If you want to join us for more of the upcoming sessions or the previous ones, please subscribe to our YouTube channel and follow us on Facebook, Twitter and Instagram to receive regular updates. If you're already subscribed, make sure to hit that notification bell to stay updated about our latest videos. In case you missed it, my company, Lampro Event Solutions, specializes in technical services for the events industry, and we're a supplier and installer of professional sound, lighting, AV and staging equipment. If you need any of these services, including live streaming or video recording and editing, please send me a message or visit our website at www.lamproaudio.co.za. We make use of the following professional brands, namely TurboSound, Behringer and Wharftail speakers, as well as Shure, Sennheiser, Audix and Samson microphones, and Allen & Heath's range of analog and digital mixing consoles. Other processors include Radial Engineering and DBX. The following page includes the references that are used for the training sessions, including the Yamaha Sound Reinforcement Handbook, as well as a few others which can be downloaded from the link in the video description below. In session 4, we had a look at dynamics processors, graphic EQs and effects processors, and how they are used in a practical way when using a digital mixing console. We used the Allen & Heath SQ6 as a practical example, and in this session we'll have a look at the remaining types of processors, namely crossovers and amplifiers, before having a look at output transducers or loudspeakers. Here we'll cover the different types of speakers and speaker application and placement. There are two types of crossover units, namely passive and active crossovers. Passive crossovers are mostly found in passive two-way point source speakers that are amplified by one amplifier, the most basic speaker system that is available at the moment. A passive crossover is installed inside a passive speaker cabinet and will route the audio signals low and high frequencies to the designated speaker's low and high frequency drivers. The crossover acts like a filter, only allowing the assigned frequencies to go through to the right speaker drivers. Active two-way speakers make use of internal active crossovers that form part of the built-in DSP or amplifier section of the active speaker. External active crossovers are mostly used with 3- or 4-way speaker systems, commonly referred to as arrays or line arrays. Most 3- or 4-way speaker systems are powered by separate amplifiers that an external crossover or speaker management system will be needed for. Speaker management systems routes audio signals with different frequencies to a number of outputs that is sent to the designated amplifier units. The different frequencies and crossover points can be selected and adjusted to give each speaker driver the right frequency response, with additional features including dynamics processing and level adjustment. Below is an example of a loudspeaker management system, the DBX Drive Rack 4800. Next we'll have a look at amplifiers. Amplifiers are the final link in the signal processing chain before the electric audio signals are converted into acoustic energy. The function of an amplifier is quite basic. It receives all the processed audio signals from the mixing console or signal processor and boosts the audio signal to the required audio level that an output transducer or loudspeaker needs to convert the electric audio signal into sound waves. The output power of an amplifier is rated in watts. An amplifier can range from 10 watts to 20,000 watts, depending on the requirement of the relevant speaker system. Huge outdoor concert sound systems can have anything from 20,000 to 400,000 watts of total power output. Making use of more amplifiers and speakers will increase the sound pressure level that is available to the end user. When choosing an amplifier for a speaker system, make sure that the total power output that is rated in watts of your amplifier is at least 150% or double the amount of all the speaker's continuous power handling capability to ensure that your amplifier can supply enough power to all your speakers. If you have two 300 watt RMS 8 ohm speakers, you will need at least 450 to 600 watts at 8 ohms per channel to supply sufficient power to your speakers. This will ensure that you'll get enough power out of your speakers without running the risk of clipping or distorting your amp that may result in speaker damage. Speakers can generally handle big loads of power above their RMS rating without getting damaged. When an amplifier has low output power, the chances of it being overdriven is much higher and will end up with blown speakers. As a rule, more power on the amplifier end is better for your speakers. This is always an important rule to remember. Stereo or two-channel power amplifiers can generally be used in 8, 4 and 2-ohm mode, in a stereo or bridged configuration. In stereo mode, the amplifier's total output power will be split between the two output channels. In bridged mode, the total output power will be allocated to one channel, usually marked channel 1 or A. When two 8-ohm speakers are connected or linked to one another on the same amplifier channel, the resistance level will drop down from 8 ohms to 4 ohms. When a power amplifier runs in 4-ohm mode, it needs to produce more power for the 4 speakers. In some instances, a total of 6 speakers can be connected to a stereo amplifier that will drop the resistance to 2 ohms, but always ensure that the amplifier can operate safely in a 2-ohm configuration. Top-of-the-line amps can usually run with 2-ohm loads quite comfortably, but some of the entry-level power amplifiers are limited to 4-ohm loads. As a rule, 4 speakers on a stereo amplifier is always the best configuration to keep it safe, unless the amplifier that's being used is proven to handle 2-ohm loads without any problems. If we used another example, 4 300-watt RMS 8-ohm speakers will need between 900 watts and 1200 watts at 4 ohms per channel of amplifier power. If we use the amplifier in 2-ohm mode with a total of 6 300-watt 8-ohm speakers, an amplifier with a total power rating of between 2700 watts and 3600 watts will be needed. Always make sure that the power ratings on your amplifiers and loudspeakers match up. Also keeping in mind how many speakers you're planning to connect from a single amplifier. This will ensure longevity and reliability of all the components in the long run. Here are some examples of power amplifiers, namely the Crown Macrotech 12000, 9000 and 5000i. The panel on the back houses 2 XLR inputs with XLR parallel outputs that can be used to link additional amplifiers. There is a choice of 2 Speak-On NL4 connectors and 4 binding posts for connecting speakers, and the HiQ-Net connections can be used for networking. The amplifier is set to stereo mode by default, but can be switched to bridged mode with the stereo or bridge switch. That covers all the remaining processors, namely crossovers and amplifiers. Next, we'll have a look at output transducers, followed by some examples of point source and line array speakers. Output transducers converts electric audio signals or electric energy into sound waves or acoustic energy by means of an amplified audio signal that is sent to it. Output transducers are also known as loudspeakers. A speaker or a speaker driver consists of 3 parts, namely the magnet, voice coil, and cone. When the amplified audio signal is received by the coil, that is shown in yellow, it will be turned into a temporary electromagnet. As the electric signal flows back and forth through the cables, shown in orange, the electromagnet will retract and repel the permanent magnet that is shown in blue and red. That will move the coil forward and backwards, which pushes and pulls the loudspeaker cone, shown in gray, in a similar fashion that produces sound waves. The most common types of speakers that are used in professional applications are point source and line array speakers. All of them make use of low and high or low, mid and high frequency drivers. A two-way speaker has a low and high frequency driver mounted into its cabinet and is called a full range speaker system, since it covers the full frequency range of between 50 Hz and 18 kHz. High frequency drivers are small speakers that are commonly referred to as compression drivers or tweeters with a frequency range of between 500 and 20 kHz. A low or mid-frequency driver, also referred to as a woofer, are available in 8, 10, 12 and 15-inch sizes with a frequency range of 40 Hz to 5 kHz. Speakers that have frequency ranges between 30 Hz and 2 kHz are known as subwoofers or basebins and are available in 12, 15, 18 and 21-inch sizes. Both point source and line array speakers are available in active or powered and passive or non-powered options. Active speaker systems feature built-in amplifiers with DSP or digital signal processing that are matched to the speaker's drivers for optimal performance. Active speakers are also very versatile since no external amplifiers or crossovers are needed to make them work. They are easy to transport, set up, and remain a popular choice for small and medium-sized events. Passive speakers require amplifiers to work, and line array systems are still commonly used with external amplifiers and loudspeaker management systems to get the needed power and frequency response from the different drivers. This ensures optimal performance and coverage that is needed for large-scale events. There are some of the smaller line array systems that make use of active speaker cabinets, but this is usually applicable to indoor applications where the output power requirement is less than that of an outdoor speaker system that needs to cover a bigger area. Okay, so let's have a look at some speaker examples. First, we have the JBL PRX 400 two-way or full-range speaker system with a high and low frequency driver that covers the frequency range of 50 Hz to 20 kHz. This specific model is a passive speaker and will require an external amplifier to work with the needed speak-on or NL4 connectors on the back panel. They are available in 12-inch and 15-inch sizes. The next example is the JBL PRX 400 subwoofer with a frequency range of 35 Hz to 250 Hz. This is also a passive speaker that requires an external amplifier and crossover to get the right frequency response out of the speaker. They are available in an 18-inch size. Next, we'll have a look at some active speakers in the point source range, and this is the TurboSound IQ15 two-way speaker with a built-in Class D 2500 watt amplifier and DSP that includes a number of processing features including crossover, EQ, and limiter presets. The IQ range is available in 8, 10, 12, and 15-inch sizes. The TurboSound IQ18B is an active subwoofer with a built-in Class D amplifier and DSP that includes similar processing features as the IQ15. The IQ subwoofer range is available in 15-inch and 18-inch sizes. Next, we'll have a look at some line array examples. The TurboSound MV212 is a three-way line array speaker with two 12-inch low-frequency drivers and two 1.4 mid-high compression drivers with a frequency response of 50 Hz to 20 kHz. Since they're passive, they will also need external amplifiers and a loudspeaker management system to work effectively. The following example is the TurboSound MS215 subwoofer, a dual 15-inch cardioid arrayable subwoofer with a frequency response of 35 to 150 Hz. This is also a passive speaker that needs an amplifier and a loudspeaker management system to work optimally. The D&B Audio Technique J-Sub and J12 line array speaker system is a high-end line array system that is used for various applications, providing exceptional sonic performance and clarity. We'll be having a closer look at the process of array processing with D&B Audio later in this session. Before we have a look at speaker application and placement, I quickly want to show you what a typical two-way active point source speaker looks like. This is the Wharfedale Titan 12D, an entry-level active speaker that is used for very basic PA applications. You can clearly see the individual high and low frequency speakers. The high frequency or compression driver produces your high frequencies from 500 Hz to 20 kHz. The low frequency driver or woofer produces frequencies between 55 Hz and 5 kHz. Point source speakers usually have an angle of 110 degrees horizontally and 45 degrees vertically that it can cover, so the right speaker placement is very important. If we have a look on the back, you will see a 2-channel mixer with XLR TRS combo inputs at the bottom that can be used in either mic or line mode on channel 1. If you want to use the speaker with a microphone connected directly to it, you simply switch it to mic mode. And to use it with a mixing console, it can be switched to line mode. Or channel 2 can be used as is. Just remember to switch channel 1 back to line mode when using it with a mixer to avoid speaker distortion. Each channel has its own level adjustment that can adjust the overall incoming level into each channel and the high and low parametric EQ will adjust the high and low frequencies of the speaker. So let's have a look at loudspeaker application and placement. This is a topic that will also be discussed in our next session that will deal with front of house and monitor mixing for live sound reinforcement. When choosing a speaker system for a venue or a specific application, you need to ensure that it will give sufficient coverage and if the type of speaker is well suited for the venue or the type of event that will be hosted. Point source speakers are ideal for small and medium-sized venues and audiences, and they're also used for stage monitoring purposes. Point source speakers can cover short distances up to 30 meters before additional delay speakers will be required. Line array speakers provide better coverage and provides higher SPLs over larger areas of up to 100 meters, depending on the size of the speaker system. If you need to work out how many speakers you may need for an event, I always use the basic rule of 10 to 20 watts per person to determine the overall amount of speakers that will be needed. If you have an audience of 100 packs, a 1000 watt or 1 kilowatt speaker system will be adequate for general applications, and a 2 kilowatt speaker system for shows that involves live music. An audience of 1000 packs will need a minimum of 10 to 20 kilowatts of total output power for sufficient coverage. The correct placement of speakers in a venue is very important, and a number of factors need to be taken into consideration, including the venue's acoustics and the audience location. The simplest way of placing a basic two-way speaker system is on either sides of the stage that is pointed towards your audience area. Point source speakers typically have a 45 to 110 degree angle, so the speakers need to be pointed to the audience area accordingly to get optimal coverage. The following illustration will give you a better idea of the placement of point source speakers. As you can see, the whole audience area is covered by the angle of the two speakers. Some comb filtering or phasing may occur in the center areas where the speakers overlap, but this is not uncommon with point source speakers. Comb filtering or phasing is the process where the same frequencies that are emitted from a number of speakers or the reflection of those frequencies will cancel each other out when they overlap each other. This will make the speaker system sound different in different areas of the venue. If the two speakers were placed next to one another, the comb filtering or phasing will be a lot more noticeable. It is therefore very important to place your speakers correctly to get optimal coverage and the right frequency response out of them. Line array speaker systems feature multiple identical loudspeakers that are arranged in a vertical line that's more suitable for large and medium-sized venues as well as various outdoor applications, since they can cover larger areas more effectively when the correct amount of speakers and speaker angles are used. A vertical line array produces sound waves that are a lot more directional in nature that minimizes phasing or comb filtering problems. The number of speakers in the vertical line can also be controlled and adjusted independently from one another, so the sound waves can be sent farther than traditional point source speakers. Some of the smaller line arrays can be ground stacked, but for optimal coverage, most line arrays will be flown or hanged. When a line array system is correctly installed, it allows for even frequency response and clear sonic coverage throughout the range of the system. Unlike point source speakers, you can add more volume to it by adding additional speakers to the line. Here's various configurations that a small line array system can be used in, including 2 ground stacking options and the flown array options. As you can see, a small or large number of speakers can be added to the flown array, depending on how many units may be needed for a desired application. As you can see by the following illustrations, the line array speaker system will give the audience much better coverage in SPL-related terms and sonic clarity that the point source speaker at the bottom can. The line array provides constant sound pressure levels to the entire audience, and the directionality of the different speakers lowers the possibility of phasing and comb filtering issues, which in turn provides clean and clear sound that everybody can enjoy. The point source speaker at the bottom will have a significant drop in SPL towards the back of the audience, which will require additional delay speakers at the back. This in turn can affect the overall response of the speaker system, where phasing or comb filtering problems may be more common. Here's a short video that will explain how line arrays must be used correctly in order to get the best result by using a technique called array processing. This video is brought to you by D&B Audio Technique.
Line arrays have dramatically improved the reproduction of sound for large audiences. The associated software has also evolved to a stage where the performance of complete PA systems can be comprehensively simulated. While this is already a huge improvement to the situation from before, arrays can still be optimized further to provide an even better tonal balance and level distribution. This goes beyond what is achievable with precise mechanical aiming alone and relies on the individual processing of every box in the array. D&B's approach to this technology is called array processing. To use array processing effectively, correct venue data and meaningful splay angles are required. The vertical dispersion of an array depends on its length and mechanical shape. It is also frequency dependent. This means that the tonal balance, or spectral distribution, and the level, or spatial distribution, cannot be completely consistent. This fact is visualized in the level over distance plot in ArrayCalc. The tonal balance is only consistent in areas where the two frequency lines are parallel. Mathematically, a solution can be derived that makes the tonal balance completely consistent. Let's investigate this for 3 example frequencies. To achieve constant level for a given frequency over the audience area, the array would need to have a specific mechanical configuration. However, to achieve exactly the same result, even for a neighboring frequency, the array's shape would have to be completely different. Obviously, a real-world array can only have one given mechanical shape at a time. Still, by applying complex FIR filters to each cabinet individually, the equivalent of the required mechanical shape can be achieved virtually. This purely mathematical approach has been tried, but the results did not meet our sonic expectations. Instead, the processing is calculated in a way that morphs along the array rather than making sudden and drastic changes. This means that the virtual shape of the array is transitioning smoothly between frequencies, resulting in the sonic footprint known from D&B. So, what is array processing actually doing? When a room model and the array designs are finalized in ArrayCalc, the array processing option can be enabled, which triggers the analysis process. The performance of an array is analyzed for a large number of receive points along all listening planes within its coverage. For every receive point, the sound of every loudspeaker is calculated across 240 individual frequency bands. The optimization process evaluates a predefined target frequency response, user-definable settings for level over distance, and processing emphasis. The result is a clever combination of FIR and IIR filters for each individual cabinet. This method keeps the additional system delay for array processing at just 5.9 milliseconds. So, what are the benefits and most important effects? With array processing, an array creates a constant tonal balance throughout its entire coverage with a user-definable level distribution. This is done by redistributing energy from areas where the sound is too loud to areas where more SPL is needed. Array processing also provides seamless compensation of air absorption at high frequencies. Array processing uses a general target frequency response for all arrays in a project, meaning that different arrays, for example main hang and outfill, will generate the same spectral result at the listener, despite having different length, splay settings, or even speaker type. Array processing adapts and evens out the vertical directivity, which can result in a more consistent direct-to-diffuse sound ratio and enhanced intelligibility, especially in reverberant spaces. Array processing improves the D&B line array system performance significantly and is the next level of democracy for listeners.
Hopefully that gave you guys a good idea of how line arrays can be set up and implemented properly. That is vital to proper line array speaker performance and frequency response. If you want to have an in-depth look at any of the speaker examples, please let me know. Okay, so that's it for the 5th session of our online sound training course that covered crossovers and amplifiers as well as loudspeakers. Our sixth and last session will give you some tips on how to achieve a good live sound mix that is applicable to both front of house and monitor mixing. Please remember to like and to follow us on Facebook, Instagram and Twitter, and to subscribe to our YouTube channel for all the sessions and reviews. As always, if you have any questions or comments, please leave it down below. And thanks guys, I'll see you with the next one.